Hi, this is Gary Rubenstein. I'm in the process of making a multi-video series. It's at part 10 right now. When done, it will probably be 20 parts of math from the perspective of a lifelong math teacher of almost 30 years. What I think about math topics ranging from kindergarten going all the way up through high school. And in the last video, I introduced algebra, which I introduced as a process for finding unknown values, something like x plus 2 equals 8, and doing it not by just, oh, that must be 6, but it's not algebra when you just say, oh, it's 6, I could tell because 6 plus 2 is 8, but algebra is when you sort of do stuff to both sides of an equation, usually with the goal of getting the x, the unknown, isolated, and then having what that value is. Once you know basic algebra, you can start doing some more advanced things. And in this video, I want to show you what's called, and this is probably the most difficult word that's come up in all these videos so far, polynomials. Well, a polynomial is basically an example of a polynomial is something that has like an x and then like a number like x plus 5. That's a polynomial. Actually, x by itself officially counts as a polynomial. Basically, a polynomial is an expression that has some kind of variable, and it might have more than one variable, and it might have variable, added to numbers, things like that. If I have two people, and person A, we don't know, person A's age, we don't know, and person B, we know that they are, let's say, 5 years older than person A. We could say their age is x plus 5. So the x plus 5 is like a polynomial. And you could do things like, what if I tell you that together their ages, combined ages, are 25. So you can make an equation out of this. You could say like, oh, well, the first person is X years old. I don't know how old they are. The other person, I don't know either. But you see, if the other person's age was called like the letter Y, that wouldn't be that helpful. Because two people can add up to be 25 years old. One could be 20, the other could be 5. One could be 12, the other could be 13. But if the other person, if we know that they're 5 years older than the first person, we get this equation. And then we can simplify things. When you add two numbers together, if you take two numbers that are the same, like 7 plus 7, you get 14, which is the same thing as 2 times, I'll use a little dot there, 7. And 8 plus 8 is 16. That's 2 times 8. Well, x plus x, we don't know what x is, but whatever it is, the answer is going to be the same thing as 2x's, 2x. So this turns into 2x plus 5 equals 25. And from the last video, we saw that this is known as a two-step algebra problem. You take away 5 from both sides, and then you divide both sides by 2 to get x equals 10. Now, this question about the two people's ages, it's not a very practical question. It's just kind of like a riddle that gives students a chance to practice doing their algebra, because just solving for x, like if you just give someone this equation, they really may not care at all what the value of x is. But if there's two people and they kind of can imagine, no, I take two people, one person's 5 years older than the other, it makes it a little bit more fun to answer those questions. Word problems of this sort have been around for thousands of years, and they're not like practical. It's not like, oh wow, now I know algebra, I can figure out if there's two people and I know that a combined age, I know one person's 5. No, it's not practical. It's just some kind of riddles that you can do, and people like to do riddles. Many people do. Okay, so let me get back to the topic at hand, polynomials. So the type of polynomial I'm going to concentrate are polynomials that are like, have an x part with a number in front of it, like 3x plus 5 or 2x minus 7. I just want to focus on these types of polynomials. These were what we saw in the last video on one side of the equation when we were doing algebra problems. Very often in math, we have expressions like this: something times x plus something, or something times x minus something. Officially, this is known as a linear binomial. Binomial because there's two sort of parts to it. And linear, well, that's because there's no exponents, which we're going to see in the next video. So, these linear binomials, what can we do with them? Well, one thing we can do with them is we can add them together. I'll put parentheses around them just to show you that these are like two things. Well, when you add these things together, it's kind of like if I have 3 dogs and 5 cats and 2 dogs and 7 cats, what do I have together? Well, the 3 dogs and the 2 dogs become 5 dogs, so this is like 5x. And 5 plus 7 is 12. So adding 2 of these linear binomials together, the answer generally becomes, this was actually a minus up here, I'm just going to make it a plus there, make it easier. So you can add these binomials, these polynomials together. We call this combining like terms. When you put the x's, 3x and 2x, just like 3 dogs and 2 dogs is 5 dogs, becomes 5x's. And 5 plus 7, of course, that's just 12. We can subtract polynomials. I'll say 5x plus 8 minus 2x plus 4. So I have the 5x minus the 2x, which is 3x, and the 8 minus the 4 is plus 4. So we can subtract binomials also. But a very difficult thing to do is, how do you multiply these linear polynomials? I'll just call them, I'll call them linear binomials. For instance, x plus 3 times x plus 5. In algebra, once we have x's involved, then the x for multiplication could really confuse things. So usually we just make a dot, which is also confusing because it looks like a decimal point, but it's like not on the bottom, it's in the middle, and then there's a context to it. But it is pretty confusing. And often when you have stuff in parentheses, you just don't put anything in between them at all. And it's an implied multiplication. So what is this? Well, I want to compare this for a second to multiplication of just numbers. I want to change this to 2 and 4 just so I can make a more dramatic point here. A mistake that children sometimes make in doing a question like this is they try to just multiply, 2 times 4 is 8, 1 times 1 is 1, and of course that's not right. No, to multiply 12 times 14 is not 18. You can't just multiply the way that you add, just working your way down. But actually it involves 4 different multiplications. It involves 2 times 4. It involves 1 times 4. It involves 2 times 1. And it involves 1 times 1. If you watched my multiplication video, I might have shown you what's called the area model, where if we think of 12 as 10 plus 2 and 14 as 10 plus 4, and the area of this rectangle would be whatever 12 times 14 is. And the area can be broken up into 4 things. This is a 10 by 10 square, which is 100. On the right here, we have a 2 by 10 square rectangle, which is 20. On the bottom left, I have a 10 by 4 rectangle, which is 40. And on the bottom right, I have this small 2 by 4 rectangle. And those 4 things add up to 168. So the reason I show you this is even though we don't know what the value of x is in this thing over here, I can make a similar picture. Now it's funny, even though I don't know how big x is, maybe x is smaller than 2. It doesn't really matter though. For drawing my picture, even though it's not like drawn to scale, because I don't know, is x a big number, is x a small number? We just make it any size we want. Now, this rectangle is 2 by x, because if there's an x here, there's an x there also. I should really label all these. This rectangle on the bottom right is 8, and on the bottom left is 4x. But in the top left, this red one, well, that's a little confusing. When you multiply x times x, what happens? Well, let's look what happens with numbers. 5 times 5 is 25. Well, that doesn't help us. With x times x, we don't know what x is. But another way of writing 5 times 5 is 5 with a little 2 up here. 5 to the second power. And 3 times 3 can be written as 3 to the second power. So x times x can be rewritten as x to the second power. And that's what goes there. So the answer to x plus 2 times x plus 4 is not, as some people might, I could see somebody saying, well, maybe it's x squared plus 8. That's kind of like the person who says that 14 times 12 is 18. They only multiplied this times this, the 10 times 10, the 1 times 1, and the 2 times 4. But instead, the answer to this question, the product of x plus 2 times x plus 4, is actually a more complicated thing. When you added 2 binomials, you got another binomial. When you multiply them, you get x squared. Now this 2x and 4x can be combined, like 2 dogs and 4 dogs is 6 dogs, so 6x plus 8. And that's an important thing that you have to do in math a lot, is multiply binomials together, you'll see in later videos why we would ever really want to do that. So what this means, it's kind of a weird thing. It's like, what is this actually saying? It's saying that if you pick some number for x, like imagine what if x equals 5? Well, then this left side would become 7, which is 5 plus 2, times 9, which is 63. And if I plug 5 into the x's for the right-hand side, I would get 5 squared plus 6 times 5 plus 8, which is 25 plus 30 plus 8, which is 63. And that would work no matter what number you put in for x. Pick any number you want for x and add 2 to it and add 4 to it and multiply them together. And then start over and take that same number and multiply it by itself, add it to 6 times that number and add 8. And the left and right side will always be equal. But it's a real abstract idea to talk about what's x plus 2 times x plus 4. It's like, well, I don't know, because I don't know what x is. Well, they're saying it doesn't matter what x is. So I'll just say, for x equals 3, let's say, x plus 2 would be 5, x plus 4 would be 9, so that would be 45. And they're claiming that if I start over and take the 3 and run it through this pattern, 3 squared plus 6 times 3 plus 8, which is 9. Something went wrong there. Well, it's not 5 times 9, is it? It's 5 times 7, it's 35, because it's x plus 4. See, this is not a scripted video. This is just me musing. 9 plus 18 plus 8 is 27 plus 8, which is 35. So that's what that means. That's a relationship between two expressions. Now, the expression on the right-hand side, this x squared plus 6x plus 8, that's not a linear binomial. It has 3 terms, and it has this exponent of 2 here. This instead, because it's 3 terms, it's called a trinomial. And because the biggest has an exponent there of 2, we call it a quadratic. Quadratic trinomial. Now going back to this question, x plus 2 times x plus 4. Remember this picture? X, 2, 4. I really like this area model. A lot of teachers make like little cutouts, like jigsaw puzzles out of these. I've been doing that for many years. Anyone who says that this is, a new crazy Common Core thing. This is not a Common Core thing. This picture of the area model has been around for thousands of years. It's a great tool for analyzing math. In China, in 500 BC, they use this as their way of doing very sophisticated math. Anyway, I did want to show you, there's sort of a shortcut for getting these 4. So a shortcut for getting these 4 rectangles, which I'll just remind you was x squared, 4x, 8, and 2x. And it reminds me a bit of what you do when you do multiplication, like 12 times 14, and you end up multiplying, doing 4 different multiplications, 1, 2, 3, 4. Well, those 4 multiplications is kind of like taking each of the numbers. Ooh, that got really, I can't even hardly see what that looks like anymore. We sort of pair up each number from the top number with each one on the bottom. Well, if you do that when it's like side by side like this, it looks like this. These are sort of the 4 sort of combinations of things that happen. So if you take the thing on the left times the thing on the left, you get x squared. If you take the thing on the left with the thing on the right of the second one, you get that. If you take the thing on the right of the expression on the left, you take the thing on the right, and then you take the thing on the left on the other one. And finally, if you take both things on the right, you get the same 4 things. Well, in math, this is sometimes, at least in America, we call it FOIL. F-O-I-L. Basically means, F means take the first thing from each binomial. O means take the outer things, like the first thing from the first one and the second thing from the other. I stands for inner, which is the 2 and the x, and L stands for the last. So call that FOIL. If you took math any time in the last 50 years, 60 years, your teacher probably mentioned about FOIL, and maybe you forgot, what they meant, but you remembered that they use the word FOIL a lot. I don't know what they call it in other countries. They might just, I don't think they call it FOIL there, because I've talked to people from other countries. Anyway, that's multiplying binomials together. So in this video, I've showed you how to add and how to subtract and how to multiply. These polynomials are things that it's sort of like the vocabulary. It's like if you were learning music and you needed to learn like your scales, like being able to, first you learn how to manipulate numbers and add them and multiply them and divide them. And then you start getting more abstract with these like polynomials that have x's, variables, and numbers in them. And you start combining those and adding them. And then you can do more sophisticated math. So we're going to build up. In the next video is going to be a real important one, part 11. It's going to end with the famous quadratic formula, one of the hallmarks of math, of school math, one of the most important formulas ever made and just really clever. And that's coming in part 11. I welcome comments. Most people get lost at some point in their math education. Like there's just some point where they sort of give up on trying to understand it and say, I'm just going to fake my way through it from here on in. And they don't get, very far after that. It would be like trying to learn a language by just memorizing sentences as a bunch of random, sounds that are not like cut into words that you can use those words in other pieces. So people, at some point, they get confused. Maybe it's when they're dividing fractions and they have to flip the denominator, whatever it is. I'd be curious where, if you're still with me on this video series, if you haven't fallen off the treadmill yet, but if you have, I'm interested. At what point? Where was like your breaking point? And maybe if you really struggle with this thing over here, maybe the problem is that you really fell off, much earlier, like when I was doing multiplication and you kind of skimmed through that, or didn't digest it and needed more practice on that. And this is more of a symptom of some other deficiency that happened earlier. Anyway, either way, polynomials are very important to be able to do any more complicated math. So I wanted to dedicate this video just to those. Thanks for watching.